Morning, grade 7. Today we're going to talk about finding the area of trapezoids and irregular figures. So in order to find the area for trapezoids, we're going to learn a new formula. And then for irregular figures, basically we're going to keep applying all the different formulas we've worked with, but you have to apply a little bit of logic and problem solving skills. So first of all, let's take a look at our trapezoids. So you'll remember that when we want to find the area of a rectangle or a parallelogram, we do area equals base times height. I'll make my pen a little bit smaller. Now, we don't have a formula for finding the area of a trapezoid, but what I want to do is I want to show you what that formula is and why it works. So you're going to notice over here that I have an upside down trapezoid that is an exact replica of my original trapezoid over here. Okay. Now, unfortunately, I'm a little bit restricted due to working on an iPad, but what I want you to imagine is that this trapezoid here slides right over to be in line with the other trapezoid. If I slide it over, because it's a picture I took off the internet, it covers up different lines. But you can picture that happening, okay? It slides over. Now, if you can picture the missing lines, when it slides over, it actually becomes a parallelogram. You can see that there, okay, where we have two sets of parallel lines that never cross each other. Now, what we know, like I said before, was that the formula for the area of a parallelogram is base times height. So if you think about that carefully, if I take a trapezoid, I flip one upside down, and I have two trapezoids, and those two together become a parallelogram, okay? What I know is that two trapezoids equals a parallelogram. I can use that information to find, if I wanted to, the area of my parallelogram, which I can then use to find the area of my trapezoid. So what we can actually figure out is that the area of a trapezoid is really the base, I'm just going to leave that blank, times the height, and then divide by 2. Now, what I get that from is what I'm going to do is I'm going to find the base of this huge parallelogram, which I notice is these two numbers together, 9 centimeters and 4 centimeters. So I really have 9 plus 4 as my base times height divided by 2. Now, if you imagine, if I get rid of this divide by 2, you can figure out the area of just my parallelogram. If I do 9 plus 4 is 13 times my height, and my height is 5, I can find the area of my entire parallelogram. But remember that my parallelogram was made by two trapezoids. So if I want the area of just the trapezoid, I just take the area of my parallelogram and split it in half. So I get 13 times 5. 13 times 5 is 65 divided by 2. Again, I want to squeeze on the bottom, but I'll move it over here. And then I get 65 divided by 2 is 32.5 centimeters squared. So again, you don't completely follow why this formula works, but it does work. So essentially, just remember, if I had a trapezoid, I flipped it over, so I double the trapezoid, I find the area of the whole parallelogram, and then I divide by 2 to get back to one of those trapezoids. So let's try that with this example here. So we have the area of a trapezoid. So remember, my formula is area equals really base 1 plus base 2, because there's two different ones, times the height divided by 2. Like any formula, you take it step by step and you plug in what you know. My base 1, I'm going to do is 8 plus the other base. Remember, I'm picturing that I flipped it over to double it to make it a parallelogram. Don't forget those brackets. The brackets are important. Times my height. Now remember, my height here is 4. It's not 7. 7's not the height. That would be helpful if I wanted to find the perimeter. And then I divide by 2. So I get area equals 8 plus 6 is 14 times 4 divided by 2. I should be able to do 14 times 4 in my head because I think 10 times 4 is 40. 4 times 4 is 16. I get 56 divided by 2. And then I split that in half and I get 28 square units. I wasn't given any units, so I'm just call it square units. Okay, so that's one type of thing that you're going to need to apply in today's lesson, is finding the area of a trapezoid given this new formula. The next thing we're going to do is we're going to talk about areas of irregular figures. So you've already been able to figure out the area of squares and rectangles, but now what if you get a shape like this? Whenever you get an irregular figure, what you need to do is split it into figures where you know different formulas to figure out the angle. So let's see if I can get a dotted line going here. So if I look at this, I can think to myself, I'm going to split this strange shape up into two different rectangles. Okay, so I'm going to have rectangle, I'll call this one rectangle 1 and rectangle 2. So then I want to find the area of rectangle 1. Now this is where you need to be careful. You need to make sure you're looking at the correct measurements. So if I want to find the base of rectangle 1, it's 7 centimeters because that line goes all the way across here. So I get area equals 7. That's my base. Now I need to do times my height. Now this is why I said you have to be careful. Notice 6 centimeters is not the height of this new rectangle that I've created. I'm working in rectangle 1. Let me just highlight that for a second. Here's my new one. 6 centimeters is not the height. 3 centimeters is. So I'm going to do 7 times 3. Area 1 equals 21 centimeters squared. Then I want to find area 2. So again, I have base times height. Area 2 equals, well, my base is 5 centimeters. And again, be careful. I'm looking at my height. What's the height of this new rectangle I created? Well, it's 3 centimeters. So my area 2 equals 15 centimeters squared. Now, that's really just the first 2 steps. Your final area is going to be those 2 added together. So I get 36 centimeters squared. Now, some of you might be saying, yeah, but Ms. Sayaf, isn't there another way to solve this? There is. If you wanted to, you could draw your dotted line this way. Pretend this one's gone, okay? And then you could do 5 centimeters times 6 for this big box, which would give you 30. And then you could do 2 times 3 for this little rectangle, which would give you 6. 30 plus 6 is 36. There's multiple different ways to attack a problem, just so you're aware. Let me show you one more way. So this is the exact same picture. Another way to do it is to think of this shape as, one big rectangle with a chunk taken out. So I can pretend it's just one big rectangle, and I can do area equals base times height, area equals 7 times 6, area equals 42 centimeters squared. That's if the whole thing were a rectangle. Now what I can do is I can actually figure out the area of this space right here that's not part of it. So I can go, well, area goes 2 times 3 is 6 centimeters. So then, right, I can do 42, the whole box, take away this tiny little chunk, which was 6 centimeters, and I get 36 centimeters squared. So again, I've shown you 3 different ways where you can find the exact same answer. Now let's apply that thinking to a problem like this. So here we have a very unique shape. What we're going to do is we want to find out the area of just the orange section. Now, obviously we have no formula for a shape like that. It's just a very irregular polygon. But what I've noticed is a few things. The first thing I notice is that overall, my shape is a triangle. That's going to be helpful. Okay, I see a triangle. Then I notice that I'm missing chunks of rectangles within my triangle. And I know things about finding the area of triangles and finding the area of rectangles. So just like in the slide before, what I'm going to do is I'm going to pretend the whole triangle is there and start by figuring out the area of my triangle. So area of my triangle is area equals base times height divided by 2. Area equals, well, I know my height, but I need to think about my base. Well, that's not a big deal because I have all the pieces of information. My base is 8 plus 7 plus 3. So my base is actually 18 millimeters times 13 divided by 2. So again, the information is not necessarily obvious, but I can get there. And go down to the side. 3 times 8 is 24. 1 times 3 is 3 plus 5. 0, 8, 1. And I believe I get 134. You can always correct me if I'm wrong. So I get 134 divided by 2. And so then I get 134 divided by 2. I should be able to do that in my head. And I get, I think, 67 millimeters squared. Okay, so that's the area of my entire triangle. So I'm just going to erase this to give myself a little bit more room. Remembering the area of my entire triangle. But now remember, my entire triangle is not orange. So what I need to do now is take out the chunks that are not orange. I'm going to start with that pink one that I highlighted. And I know that 5 times 3, or 15 millimeters, is missing from my orange triangle. Then I'm going to do my blue one. Again, 7 times, I almost did 3, careful, the height is 2. 7 times 2 equals 14. So now I know that 15 millimeters and 14 millimeters, which is a total of 29 millimeters, is missing from my triangle. Okay, that's not shaded orange. So I'm going to take my original. If the whole thing was orange, it would be 67. It's not. Oops. So I'm going to take away the 29, which represents the area of those two triangles. And I do 17, take away 9 is 8. And I end up with my final answer is 38 millimeters squared. Okay. So you see, it's really just applying all the different formulas that you know, step by step by step. All right, let's do one more like that. So again, always look for familiar shapes when you're looking at an irregular figure. So the familiar shape that I can see here is, I can see a triangle and I can see a rectangle. Pretend my line is straight there on my triangle. So let me start by figuring out the area of my rectangle. I'm going to call it shape 1. Area 1, area of a rectangle is not a big deal anymore. It's base times height. My height and my base is 16, goes all the way across, times 7. 16 times 7, so I should be able to do that in my head. If I think 7 times 10 is 70, and then I think 7 times 6 is 42, and then I add them together, I should get 112 centimeters squared. Don't forget that little squared. So that's the area of area 1, the rectangle. Now I need to find the area of area 2, which remember is base times height divided by 2. So we need to ask ourselves the question, what is the base of this triangle? Well, if I look over here at my dotted line, the base is part of this rectangle. Now I know that the base of my rectangle is 16 centimeters. And then I know from over here in this corner to over here, I've used up, so to speak, 8 centimeters. So that means this remaining part must also be 8 centimeters, because what I did was I did 16 take away 8 is 8. So now I know my base. So my base is over here, 8. And now I need to find my height. We're going to use the same logic. This whole line is 13 centimeters. But then I know that part of this line, let's see if I can do it in a different color. Part of this line from here to here, I know from over here is 7 centimeters. So I do 13 take away 7, and I get that the height right here of the actual triangle is 6 centimeters. So again, it doesn't explicitly give you that, but you can figure it out. So then I would do 8 times 6 is 48 divided by 2. And then I would get 24. Now remember, don't stop there. Now do the final step of adding the two different shapes that you found. So we would get 136 centimeters squared. So the biggest thing for this lesson, grade 7, is to take it step by step, break it down, and then use the formulas you know. Feel free to call me if you have any questions, and I hope you have a great